So looking ahead, or kind of a quicker turnaround on this test. Only a week or so. We'll test. Oh, Mr. Conley and I need to discuss if we'll test Monday or Tuesday or both days. We need to figure that out. Also might be affected by if we have school tomorrow or Wednesday, if you're watching the weather. If we only miss one day, we'll be able to catch up on block day because today and tomorrow it's the same topic. Just because it's an important topic, we spend 2 days on it. So really all the notes are today. Tomorrow I'll work questions from today's assignment and give you time to work on another assignment that covers the same stuff. So if we have to go virtual for a day or miss a day, Tuesday's not a bad one to have to miss. So hopefully we'll be here tomorrow. It looked like the thing turned inward a little bit, so we'll hopefully be here, but we'll see. But I'll keep you up to date via Schoology if something changes. Just generically, the stuff from last unit, the test you just got back, that is foundational the rest of the year. Product rule, quotient rule, chain rule, those key rules about power rule, trig rules. Like now we're going to continue to use those. This is not like, math is always like this, right? It's not like history where, okay, that was the Civil War, now we're moving on to, Reconstruction, and Ben, you should know what happened in the Civil War, but you could kind of put it behind you, and because the next test is all going to be about Reconstruction rather than the Civil War. Math doesn't work that way, right? Like once you learn how to add, you got to keep knowing how to add. Once you learn how to multiply, you can't just forget that for the next test. That's especially true. It's always true, but it's especially true for that test we just took. Limits, sometimes we don't use those. Definition of a derivative, don't use that very much. But those rules for how to take a derivative, the shortcut rules, those we're going to continue to use, probably every day. So most of you did fine, so that's good. But if you got stuck on one of those rules, you forgot something, you forgot the chain rule, whatever, you've got to figure that out because we're just going to keep using it. I don't know what to say other than it's not one of those things where you can just, oh well, I didn't do well on that test, I'll do better on the next one. I hope you do, but unless you learn what was on the last test, you probably won't do well on the next one. All right, implicit. One more generic comment. If you look at the calendar, today and tomorrow are implicit, and then block day and Friday are related rates, and then we test. So you tell me, what do you think it means that there are two things on this next test? What do you think that means? They're big, yep. What else might it mean? Might be a little bit shorter test because there's only two topics. What about the relative difficulty of said topics if we're only going to cover two of them? They might be on the harder side of things. Right? If it was easy stuff, then we would throw 4 or 5 or 6 things in there. Kind of like the last test. Not that was easy, but all of those little individual rules, it'd have been, I guess we could have tested on 2 rules at a time, but that wouldn't have been much to test on. Implicit and related, they go together, so that's at least good news. But they are a little bit trickier until you get the hang of them. So we're going to spend a whole week on it. It's only 2 topics, but they're not easy. So just fair warning. All right, implicit differentiation. Let's go with the back end first here. Differentiation, that means take a derivative. Implicit. What's the opposite of implicit? Explicit. An explicit equation is one that's solved for y, like it's explicitly solved for y. Y equals whatever. That's an explicit equation. So an implicit equation is an equation not solved for y. And we hadn't really talked about this before because all of the equations up till now were explicit. They were all y equals something. And so on the left-hand side, you took the derivative and you got y prime. That was easy. On the right-hand side, you had to use all the rules with chain rule and power rule and product rule and all that other stuff. Today, we're going to use all those rules, but y is going to be sort of buried in the equation, and we'll have to pick it out and solve for y prime. Let's do an example with the chain rule. Let's take the derivative. Helps if you have a color for this, but it doesn't matter because a regular old triangle would work. I just happen to prefer green triangles. Let's take the derivative of the cube of a green triangle. I know you're like, what? Why? What? X's and Y's, okay, but triangles. Well, ignore the triangle. How do we take the derivative of something that's cubed? Yeah, it's still the power rule, so 3 times whatever was cubed is now squared. So 3 times green triangle squared. But that's not it. That's not all. I mean, that's right. It's just not finished. Because we have to also consider what the green triangle is, right? Like, if that was a sine, then we'd have to multiply by cosine. If it was a tangent, we'd have to multiply by secant squared. Like, there's a chain rule going on. We have to multiply by the derivative of the green triangle. So let's do that with y cubed. Let's take the derivative of y cubed. So power rule is still the same, 3y squared. But we're not done. We have to multiply by the derivative of y. So dy dx. And again, what's new about this is we've not really seen y cubed before. We'd only seen y up till now. What we had done before is take the derivative of x cubed, which was 3x squared, and we didn't even concern ourselves with the chain rule. But if we had, take the derivative of x with respect to x, well, there's a lot going on behind the scenes here, but you know enough to know what's dx over dx probably equal to 1. Even if you're not exactly sure what that means, it's a fraction, or the top and bottom are the same, so it's 1. So we've kind of done the chain rule. We just don't really use it when there's x involved because it just goes away. Today y is going to be involved, and so we're going to have to remember to put dy dx on there. This is going to be the main thing. People forget to put dy dx on there. Let's do some examples. Solve for dy dx. Which I guess, I mean, that's it for new notes. Like, we're ready to start working some examples. It's just wherever there's a y, if you take a derivative, dy dx is going to show up. So let's say y cubed plus y squared minus 5y minus x squared equals negative 4. And we want to solve for dy dx. So what's the derivative of y cubed? 3y squared is part of the answer. dy dx. Chain rule, dy dx. What's the derivative of y squared? Two y, but that's not all, times dy dx. What's the derivative of 5y? Oh, let's back up. What's the derivative of y? What's the derivative of x? Back up even more than that. What's the derivative of x? 1. So the derivative of y is 1, but times dy dx. Minus 2x equals 0. I guess there's a little bit of good news. If you forget dy dx on all of them, and your instructions are to solve for dy dx, and you don't have any dy dx's, you probably realize, wait a minute, something's not right here if no dy dx showed up. So the trick is, do you remember to put it on all of them? Like, you'll remember it on some of them, because otherwise you can't even work the problem. So make sure wherever there's a y, dy dx is going to show up. This is not safe stop, right? To solve for dy dx means get dy dx by itself. And yes, there's only algebra left, but this is not calculator ready. Like we haven't answered the question yet. So let's factor out dy dx from all the terms that have a dy dx. 3y squared plus 2y minus 5. I'm going to go ahead and move the 2x to the other side. So dy dx equals 2x over all of that stuff. That's implicit differentiation. I guess what makes it hard is not that, because it's just one idea. Wherever there's a y, dy dx is going to show up. It's just when you sprinkle in all the other rules, can you keep up with everything? A couple more examples. Y squared minus x squared equals 4. In fact, why don't you try that one? It's similar enough to that last one that you can try it. So take a derivative and then solve for dy dx. So 2y dy dx minus 2x equals 0. So our calculus is done, but we do need to solve for dy dx. So dy dx equals 2x over 2y, which is that's a safe stop because you've solved for dy dx. And yes, it would simplify, but that's an algebra thing. We're fine without doing that. Did I mess something up? I moved this 2x over by adding 2x to both sides.
If you stopped at, like, you simplified it, would you, like, would you be wrong?
No, I mean, you could keep going. I mean,
All I did, but I wasn't sure if it's, like, halfway in between the safe stop and, like, the not safe stop, so that doesn't count.
anything, once you get to a safe stop, any further simplification you do is fine. Obviously, as long as it's accurate. Example 3. 2x squared y plus 3y equals 5. What do you think is going to be involved in this problem? Chain rule, yes. What else? How am I going to handle 2x squared times y?
You pull out the y's, the vector of the y, product rule?
Yeah, some of you are getting more complicated than you need to get. It's a product rule.
Oh.
So I'm still going to do product rule. I'll just have to be careful because there's a y in there. So let's see, f prime. So what's f prime equal to? 4x. And what's g prime equal to? Careful. I'm okay with 1, but you're not done. Times dy dx. You could, which means you could just put dy dx. Yes. Let's see. G f prime. Well, it doesn't matter because it's product rule, so order doesn't matter. Fg prime would be 2x squared dy dx plus the other way 4xy and then now don't forget the rest of the problem. What's the derivative of 3y? 3 dy dx equals the derivative of 5, 0. I'm laughing and smiling because it's so frustrating when students get all of the hard calculus right and then forget about the 5 and like just put equals 5 over there. You gotta take the derivative of everybody. Let's see, I'm out of space. Let's see how much algebra I can do at once. I'm going to factor out a dy dx from those guys. 2x squared plus 3. What am I going to do with that 4xy? Yeah, move it over. So negative 4xy on the other side. So dy dx equals negative 4xy over 2x squared plus 3. Sometimes you can get some ugly fractions on the other side for your final answer. Remember, you do not have to simplify those. If you're checking in the back of the book or Calc Chat, they're going to do some crazy, nothing with this one, but generally speaking, they'll do some simplifying that you don't have to do. Example 4. Find the slope of a tangent line to x squared plus 4y squared equals 4 at square root 2 comma negative 1 over square root of 2. What does it take to find the slope of a tangent line? What's another word for that? Derivative. Now, I don't need to write the equation of the tangent line, just find the slope of the tangent line. This happened a little bit on the test where you got to read the directions carefully because we can ask for a variety of things. Make sure you give me the correct answer. So I don't need the equation of the tangent line. I just want the slope of the tangent line. So I just really want the derivative at that point. So 2x squared, whoops, not 2x squared, 2x. I'm going to intentionally make a mistake here. You tell me what's wrong with my answer. 2x plus 8y equals 4. I need a dy dx by the chain rule. I didn't derivative the 4. I'm not sure derivative is a verb, but yes, that's correct. I didn't derive the 4. I didn't derivative the 4, however you want to phrase that. So dy dx then, it's like how much do I want to show here, especially since I've got a messed up looking thing. Move the 2x over. dy dx equals negative 2x over 8y. Since I'm going to be plugging stuff in, I'm going to simplify that. I don't have to, but to get a final answer, I'm probably going to need to do that anyway. And then to show that we're going to evaluate it at a point, we can put this bar that just means evaluate at root 2, negative 1 over root 2. So that bar just means evaluate at. A couple weeks ago, someone in the Facebook calculus group asked, does that bar have a name? Do we call that anything? And nobody knew. Everyone just said, well, we just say that's just tells us where we're going to evaluate.
So the negative x over 4y, could that be our slope?
Well, that's the derivative, but I want a slope at this particular point. So it's not the slope at that point. It's the slope for any given x and y. But the slope at this point, I need to plug in x and y. So that's a really good question. Generically speaking, that's the slope at any point. But if I want the slope at a particular point, I've got to plug in the point that I need the slope at. Did that answer your question? Okay. So negative root 2 over 4 times negative 1 over root 2. Free response, stop, right? Like, yes, there's cleanup work to do. No, I don't want to do it. We would be done if we have the choice. Now, if it's a multiple choice test, there's a fraction in the bottom, so I'm going to multiply the top and the bottom by square root of 2. Motivated by I want to cancel that fraction in the bottom. The extra bonus is that it makes the top not square root anymore. So 2 over 4, 2 negatives go away. So 1/2 would be the likely multiple choice answer. But again, if left on your own, if that's a free response question, don't mess this up. Like, just say, I'm good enough. Leave it alone. Be good. And remember, that's the slope of the tangent line at the point we were given. It's the derivative at the point we were given. Which means it would be easy to write the tangent line now, but that's not what it asked for. It only wanted the slope of the tangent line. Last one. Find the equation of a tangent line to, let's pause there for a moment. So it asked me for the equation of a tangent line. So I've got to get a point and a slope and write it as a line. So, slow down. I think a lot of times in math, students, good students like you guys, you don't really read the question because you're used to, let me just jump and do what I'm supposed to do. Let me find the derivative, which is part of the question or part of what you need to do. But you need to slow down on these assignments and make sure you're doing what they're asking you to do. Find the equation of a tangent line to x equals sine of y at 1 comma pi over 2. Okay, that looks a little bit weird, but weird meaning it's an implicit equation. It doesn't have y equals something on it. So let's take the derivative of both sides. The derivative of x, yep, that's 1. That's the easy one. What's the derivative of sine? Cosine. Cosine of what? Cosine of y. dy dx. Chain rule times dy dx. So dy dx equals 1 over cosine of y. Which I guess equals secant of y, but why would we do that? Because if we want to evaluate it, we would just change it right back to this. So I would leave it at that. So that's my derivative at any particular point, but I want to find the derivative at, so I want to evaluate that at 1 comma pi over 2. So 1 divided by cosine of... be careful, make sure you keep your x and y coordinate straight here. I won't call anybody out who messed that up on the test. What's the cosine of pi over 2? Let's see, pi over 2 is right there. 0. What? Okay, you're shaking your head. I like that you're shaking your head because you can't do 1 over 0. But all is not lost on this problem. What does the derivative tell us about the graph? Slope. Slope is undefined. But undefined slope doesn't mean that there's not a line there. Show me with your arm what an undefined slope looks like. Yeah. So you're right to think, uh-oh, or oh no. Like, that's not good. But it doesn't mean, oh, we're done with this problem. The answer is no solution or undefined. It does mean that the slope is undefined. That's true. But an undefined slope, there is a line that has an undefined slope. It's a vertical line. Okay, so a cusp, it's a really good question. A cusp will not have, well, unless it's a specific type of cusp. Generally speaking, cusps aren't going to be an undefined slope. They're going to be, you can't do it at all. So this is going to be a vertical line. So you said that already. What kind of equation? Yeah, x equals. Thank you for answering my question before I even knew how to ask it. A vertical line is an x equals line. Okay, so x equals what? How did you get 1? Because it's to this point, so it better be x equals 1. So this is a weird situation. Here's a picture of what this graph looks like, roughly. All right, so it's like the sine graph, but it's kind of turned because x and y are backwards. There's the point we're looking at. And so it does have a tangent line. It just happens to have a vertical tangent line at x equals 1. So that's a kind of a special case, but it's to show you that if you get 1 over 0, that doesn't mean, oh, can't do that problem. It means, wait a minute, slope's undefined. I know what that looks like. And so this is a different kind of problem, but it's not one that's just done. It's just if a vertical tangent line has y prime undefined, and a horizontal tangent line, just while we're here thinking about it, we've said this before a couple times, I think. What's going on at a horizontal tangent line? Yeah, the slope is 0. Yes, sir.
So, like our original equation was x equals, did that already determine that it was going to be an undefined slope, or was it just at that specific point?
It's only at that specific point. Like, because this is the graph, so if I had asked for the slope at this point, that slope would have been whatever, -1 or something. It's whatever made the denominator 0. That was the key. And so, yeah, it had to be this specific spot that made the denominator 0. Good question. All right, the assignment. Well, this is section 2.5, so if you're calc chatting, it's page 145, 1 through 29 odd, 33 and 35. Please try those. Okay, we'll get more practice tomorrow. I'll answer some of these and I'll give you a worksheet to do some more of them. So it's a little bit of calculus, but all of the rules we've learned so far, a little bit of algebra, we're starting to mix it all together. So don't put it off. Please keep up. Picture is posted in Schoology, and obviously calc chat for answers.